guys, we're going to do lesson 14's homework real quick. And this one's a little bit more difficult without a ruler or a protractor, but you could just do your best without it if you don't have one. And I'm going to do it eyeballing as well. So this first one says for me to draw a right isosceles triangle. What that means is I have to have a right angle like this, and that two of the sides have to be equal. Excuse me. So here I'm going to do my best to make it look equal. These two sides are equal. The third one is not, so that makes it right isosceles. And I'm going to indicate they're equal with those little tick marks. Next, it's right and scalene. So I started off with my right triangle again, and then I drew something where all three sides were going to be different. Next is obtuse and isosceles. So I'm going to start off with my obtuse angle like we did today in class, but I want to make sure that two of the sides are equal. Here I'm going to put tick marks as close as I can get without a ruler. And then D says acute and scalene. Now this one, don't laugh, it took me a couple tries. So just give me a minute. So it's acute, so all three angles have to be acute, but all three sides have to be different. And so the first couple times I'm doing it here, it kind of looks acute, but some of the angles started to look right when I was doing it. So it's kind of difficult without your ruler and your protractor. Just do your best. And then check it for sure in the morning if you don't have yours at home. But I'm going to start off with an acute angle here. Nope, that's still obtuse. Let me try again. That's why having those math tools are so important. Unfortunately, I don't have them with me right now. So let's try again. Acute and scalene. Okay, so 5th time's the charm. That still looks a little bit right. I don't like it. Hold on. That works. It kind of looks isosceles, but I bet if I were to measure all three sides, none of them would be exactly the same length. Let's make it look a little bit better. Okay, there we go. I feel more comfortable about that one. Okay. The only way to really know is to have your ruler with you, so we'll measure that one in the morning. Alright, number 2 says, draw all possible lines of symmetry on the triangles above. Explain why some triangles do not have lines of symmetry. So on A, I could do it right here to where the equal sides fold on each other. Same thing on C, but B and D aren't going to have any lines of symmetry, and that's because they don't have any equal sides or equal angles when they're scaling. And so that means there's nothing that's going to match up perfectly when I fold them. And so that's what I'm going to write here. So I'm going to say the scalene triangles do not have any or have lines of symmetry because they have no sides or angles that would match up, since they're different. Alright, next page. Number 3 says triangle ABC is an isosceles triangle. Segment AB must be 2 centimeters. So is that true or false? So let's look. Well, BC is 1, AC is 2. It says AB must be 2. So I'm going to write 2 centimeters here. So does that make it an isosceles triangle? Yes or no? Well, it does, because that means that 2 of the sides are equal, which means it's an isosceles triangle. Remember, isosceles means 2 of the sides are equal. All right, number 4 says a triangle cannot have both an acute and a right angle. False. I can have one that is right, and then the other 2 have to be acute. That's the only way that it works. So that's going to be false because I drew one right here. Sorry, my dog keeps asking for attention. Alright, number 5 says triangle XYZ can be described as both equilateral and acute. That's true because all 3 sides are equal and all 3 angles are acute. All right, number 6 says a right triangle is always scalene. True or false? False. I could have an isosceles right triangle, which I'm going to draw right here. And the last one says, it's an extension, but it says in triangle ABC, x equals y. True or false? Hold on. It could be right and isosceles. Okay. On this last one, that's false. The only reason, I mean, they're not equal because it's not an equilateral triangle, but the one that would be equal to angle X would be angle C right there, where the one that's not marked, because we kind of tried to discover this in class today, but the angles across from the sides that are equal are the ones that are going to be equal. So only angle C. Thanks, guys.